So this is an example problem that's probably going to be important for your quiz coming up. All right. So, um, well, when we have a car that's going around a curve, okay, this is from the front view and this is bird's eye view. The only thing that's really keeping your car in a circular path is the friction between the tires and the road. Okay. Now, if there are no friction, or if there were no friction, subjunctive, I guess, right? What's going to happen is, as you are turning, as you are turning, right? When you hit an ice patch, your car will go straight off tangentially rather than staying in that circular path. Okay? So the friction is what's keeping your car from sliding off the road, and it's keeping you in a circular path. So this is the horizontal force, okay, in the same direction as my AC. And that's very important, recognizing what is contributing to that circular motion. Okay, so here, if we were to actually take a look at this problem, we have 1,000 kilogram car rounds a curve on a flat road. Now, this is not banked, right? It's a flat road of radius 50 meters at a speed of 50 kilometers per hour. They're nice enough to give us a conversion of 14 meters per second already. You must have your speed at 14 meters per second. So let's write down everything we know. We know the radius is equal to 50 meters. We know speed, that is going around a circular curve, is 14 meters per second. Now, will the car make the turn, or will it skid if A, pavement is dry and coefficient of static friction is 0.6, B, if pavement is icy and mu sub s is 0.25. Okay, so they want to know if this car is going to make it or not. If it is this coefficient of friction and this coefficient of friction. Now, you could solve this two ways and find out what's the safe speed for this coefficient of friction is and what is the safe speed for this coefficient of friction is. However, what if we just solve for the safe coefficient of friction at this speed? Then you could kill two birds with one stone, right? So if your coefficient of friction is less than 0.6, then you'll be able to make that turn no problem, right? But if your friction is more than this, it won't make it. It'll slide off. Same thing with this, right? If your coefficient of friction you calculated comes out to be more than this, right, you're going to be sliding off because you're going to need that much of coefficient of friction. But if it's less than this, then you'll make it. Okay, so let's calculate what the needed coefficient of friction is. So right, let's calculate the safe mu sub s. All right, so how do we do that? Well, we have to break this up into both x and y. Okay, so it's probably a good idea to do the x and y. Let's do the x, right? Let's do the x first. X, if I were to look at sum of all forces in the x direction, it is equal to MAC because it's going in a circular motion. And how many forces are acting in the x direction? There's only one, and that is the force friction. Okay, F friction is the only force there. So if I set them equal to each other, right, MAC is equal to, now the direction of AC is this way, right? Then that's the positive direction. And since friction is acting in the same direction as my AC, this will also stay positive. Okay? Therefore, mv squared over r is equal to mu times the F normal. What's my F normal? Well, let's figure it out. If I look in the y direction, sum of all forces in the y direction is equal to MAY. Sum of all forces in the y direction, there are two forces in the y direction, and that is the F normal plus the FG. Now I'm going to consider up direction positive, right? Now your car will not be accelerating up in the y direction, or you won't go through the ground in the y direction. So my A sub y is 0. Therefore, M AY, okay, MAY is equal to MAY is equal to F normal, I'm going to consider that positive, FG negative. Again, AY is 0, so 0 is equal to F normal minus FG is just MG, right? So my F normal in this case is equal to MG. So maybe we can substitute that MG into here, okay? And then we can work it out. So if we do that, we have mv squared over r is equal to mu times mg. Look what happens to my mass. My mass cancels out. So it doesn't matter whether it's like 18-wheeler or, SUV, or it really doesn't matter because it's mass independent, right? That's why we don't have like 4 different speed limit signs, like semi trucks go at this speed, or SUVs go at this speed, sedans go at this speed. Smart car for 2 don't go, right? So we don't have all these different stops, speed limit signs for different cars. So if we solve for mu, my mu then is equal to, right, v squared over rg. So now if we solve for mu at 14 meters per second, right, it will tell us if we could make this curve at this or this. Okay? So let's take a look. V squared, which is 14 squared, right? Divide that by R, which is 50 times 9.8. Don't plug in negative 9.8 because we already gave direction here already. Therefore, what do we get? So let's work it out. So here I have 14 squared, right? Divide by 50 times 9.8, and I get 0.4 as my mu. That means this is the minimum coefficient of friction needed in order to negotiate that turn, right? This is minimum. So if this is the minimum amount of coefficient of friction needed to slide off, will it make this turn at dry pavement at 0.6? So for part A, right? Dry pavement, mu sub s is equal to 60. I mean, a 0.6, I should say. 0.60. Will it make it? And the answer is yes, because now you have more than enough to negotiate that term, because 0.4 is all you need, right? Because, right, 0.6 is definitely greater than 0.40. Therefore, yes, right? But what about part B? Part B, mu sub s is only 0.25. And since you need 0.4, right? No, it will not. It will slide off, right? Since 0.40 is needed, right? Right? This is not enough, right? Therefore, the car will slide off the road. Okay. All right. So let me see if you can. You have to show me this work on your quiz. Okay. It's a good idea that you could, don't start with this. Okay. Show me this. This is more important. All right. So let's see if you can do this. I'll give you about I don't know, 10 minutes. See if you can work this out. Now, what you need to do is you need to draw me a free body diagram, right? Like this, on this. Okay, so it's a good idea to show me this, right? On this, and maybe even draw this in the bird's eye view on here as well. All right, so I'm gonna pause this and I'll come back and meet you at 9:14. All right. All right, let's take a look at this. All right. So, what is the maximum speed with which a 1,050 kilogram car can round a turn of radius 70 meters on a flat road if the coefficient of friction between the tires and the road is 0.8? So that's pretty good traction you have, right? Is this result independent of the mass of the car? Well, we could answer that. So here, assume a car right here, okay? So here's my Hummer. Okay. And Here's my 50 caliber, right? M50 machine gun mounted, right? So this is my Hummer. And let's draw some force diagram on this John. So here is my FG. Here's my FG. And here's the normal force, right? F normal. And the friction is acting in towards the circular path, right? So this is the direction of my AC, okay? And that's going to be the positive direction, okay? So if we were looking at this from the top view, right? So here's the Hummer, right? So here is the friction going in this direction, right? And that's the direction of AC, right? So sum of all forces, right? The y direction is equal to MAY, and sum of all forces in the y direction, I have F normal plus FG. So MAY is equal to F normal minus FG. AY is 0, so F normal is equal to MG minus MG, so F normal is equal to MG. Then we can say sum of all forces in the x direction is equal to MAC, because that's what's contributing to make this car go in a circular path. So sum of all forces in the x direction, there's only one, and that is the friction. So MAC is equal to friction, and they're both positives because they're both in the same direction. So mv squared over r is equal to mu times the F normal, and since F normal is equal to mg, mv squared over r is equal to mu times mg. Boom, boom. So that answers that question right there. So it's definitely independent of the mass, right? So my v then is equal to mu times g times r square rooted. So if you plug this in, square root of 0.8 times 9.8 times 70, then my v is equal to, right, I get something like 23.4 meters per second. And that's approximately 84 kilometers per hour, or around 52 miles per hour. Okay, so just to give you an idea what the speed should be. Okay, all right, so here's what you need to do for the remaining period. If you go to the Schoology, I put up 3 different problems up there. So I'll stop this recording for the lecture so you can print out your mock quiz, or maybe even worksheet that will help you with the quiz coming up on Friday. There will be also 10 multiple choice questions that you're going to have to do on Schoology, and we'll work on that first in class, and then remaining time you'll be working on the free response part on your own, right? So be prepared for that. So I'll stop the lecture here.